Okay, in this video, we are going to be testing our proof of work method to make sure that it works properly. So let's open our test.js file and we're going to test our proof of work method in here. Now, we should have some dummy data in this file from a previous video. And if you do not have this data, feel free to pause this video for a moment and just write some data down. And then you can pick back up with the video and we'll start testing. Okay, cool. So actually for a proof of work, all we need is a previous block hash and current block data. So in our test, we are going to get rid of our nonce and we are going to call bitcoin.proofofwork. And we are going to pass in our previous block hash and our current block data. And we're actually going to console log the result out. Now, what we should get as a result from this proof of work function is a nonce value. What our proof of work method essentially does is tests to see what is the correct nonce value to hash with our block data and our previous block hash to generate a resulting block hash that starts with 4 zeros. So basically what our proof of work does is finds the correct nonce for us. So let's save this file and let's run our test file by saying node dev test.js and run it. Cool. So this is the value that we got returned. This is our nonce. And basically what this number is signifying is that it took 27,470 iterations for our proof of work function to find a hash that starts with 4 zeros. To find a hash that starts with 4 zeros, it took 27,000 times. Now, to illustrate this a little bit better, what we can do is inside of our while loop, we can console log out every hash that we try. So when we run our test file now, what's going to happen is we should actually see 27,000 different hashes logged out inside of our terminal. And every single one of these hashes should not start with 4 zeros, except for the last one. Only the last hash that gets logged out should start with 4 zeros. Because after we find the correct hash, the function will always end, and our nonce will be returned. Okay, cool. So let's save this file, and our test.js file is still the same. So let's run it again. Cool. So you can see that we have a whole bunch of different hashes being logged out to our terminal. And for every single hash, the beginning is never 4 zeros in a row until we get down to our final calculation. Pretty cool. So basically, what is happening here is we are starting all the way up at the beginning, and we are generating this hash from our current block data, the previous block's hash, and a nonce of value 0. Then for the next hash, we are incrementing our nonce by 1. So it's all the same data, but our nonce is now the value 1. As we can see, this hash does not have 4 zeros, so it's not a valid hash that we are looking for. So we increment our nonce to the value 2 and we try again. And we keep incrementing our nonce a bunch of times until we finally get a hash generated that has 4 zeros in the beginning. So we had to increment our nonce 27,470 times to generate the correct hash. That's pretty cool. Now let's try using our hash block method. So we will delete this and we will say bitcoin.hashblock. And if you remember, our hash block method takes in a previous block hash, current block data, and a nonce. So we'll pass in our previous block hash, our current block data, and what value do we want to pass in as a nonce? Well, by doing our proof of work, we found the correct nonce, which is this value right here. So we'll take that value and pass it in as our nonce. Now let's log it out to the console. And what we should see here is that by doing this single hash with the correct nonce that we found by doing our proof of work, we should generate a hash that starts with 4 zeros on the first try. So let's save this file and let's give it a try. Perfect. So we get the correct hash generated. It starts with 4 zeros, and it's actually the same exact hash as up here. Cool. So this is a very important part of blockchain technology. A proof of work is supposed to be very difficult to calculate. As you can tell, for us, it took 27,000 times to generate the correct hash. So a proof of work should take a lot of energy and a lot of calculations, and it should be very difficult to calculate. But once we have the correct proof or the correct nonce, it should be very easy to verify that we have the correct nonce value. We can verify that we have the correct nonce or the correct proof by simply passing it into our hash block method. By running our hash block method one time, we can verify that we have the correct nonce because the generated hash starts with 4 zeros. So that's very important to blockchain technology. It takes a lot of work to generate a proof of work, but it is very easy to verify that that proof of work is correct. So if we ever want to go back into our blockchain and check to make sure that a block is valid, all we have to do is hash that block's data with the previous block's hash and the nonce that was generated from the proof of work when that block was mined. If this returns to us a valid hash that starts with 4 zeros, then we already know that the block is valid. Easy as that. It just takes one calculation to prove that the block is valid. So this is pretty cool stuff. This is a very important part of blockchain technology. If you are having a little bit of trouble understanding just exactly how this proof of work is working or how it's securing the blockchain, I would encourage you to go back 2 or 3 videos and re-watch this section on proof of work. You'd be surprised how much you can learn and how much you'll pick up on the second time around. Great. So our proof of work method works just as it should. is a nonce value. Our proof of work is a nonce value. Our proof of work function essentially tests to find out what is the correct nonce value to hash with our block's data to get is a nonce value. Our proof of work method essentially is a nonce value. What our proof of work method essentially does is tests to see what is the correct nonce value to hash with our block data and our previous block hash to generate a hash that starts with 4 zeros.